So let's go through a couple more examples of multiplying monomials by polynomials using what we call the area model, or some students will call this the box method. And essentially what we're doing is we're taking this monomial for w, that's to the third power, and multiplying it by the polynomial, this quadratic 5w squared minus 3w minus 4. And the straightforward way is to just distribute, and we'll use that to check our work, but this area model can also be set up to give a more physical interpretation of what's happening here. Since when you set up this area model, we're really just finding the area of this entire rectangle by finding the area of each of these smaller rectangles and then adding them all together. So for instance, to find the area of this blue rectangle, we'll take the height of the rectangle and multiply it by its width. So we do 4w to the third multiplied by 5w squared. And 4 times 5 we know is 20. W to the third multiplied by w squared would be w to the fifth. Remember, when they have the same base, you can just add the exponents or just think it through. There are 3 w's multiplied here, and we're multiplying 2 more w's, and so in total, we are multiplying 5 w's together. Now for this next one, this red rectangle, we take 4w to the third and multiply it by minus 3w, so height times width here, and 4 times negative 3 would be minus 12. W times w to the third, well, we have 1 there, 3 here, and so in total we're multiplying it 4 different times. And lastly, we have minus 4 multiplied by 4w to the third. Minus 4 times 4 would be minus 16, and we have no w's here, so we just have the 3 w's from our height. And keep in mind that even though we cannot find a physical area of a rectangle with a negative side length, this area model still works. So this might not make physical sense, but you can still use this area or box method when multiplying the monomials by polynomials. So this is a valid answer for this, and when we actually add all of these together, that will give us our total area. So that's 20w to the fifth minus 12w to the fourth minus 16w cubed. And like I mentioned, we can check this by just redistributing, and you're going to get the same answers since we already went through this process. But 4w cubed times 5w squared we know is 20w to the fifth. 4w cubed times by minus 3w would be minus 12w to the fourth, and minus 4 times this gives us minus 16w cubed, which, like I said, is the same answer. But when you're first learning these, it's a good idea to check these by doing it a second way, by using distribution rather than using this box method. So let's do one final question here. And we are going to be multiplying this 7x squared by the polynomial 3x squared plus 8x plus 7. And again, we'll use this area model. So we just need to find the area of each of these rectangles and then add them together. So for this first one, the 3x squared times 7x squared, we multiply the numbers, the coefficients, 3 times 7, which is 21. And we have 2 x's here, and multiplied by 2 more x's there means we're multiplying x 4 different times. So remember, just when their bases are the same, you can add the exponents. And here we have 8x times 7x squared. 8 and 7 makes 56. And we have 1x there, x to the first, multiplied by x squared. So 1x times 2 x's gives us 3 x's multiplied. And lastly, we have 7 times 7x squared, which gives us 49 times by x squared. And to find our final answer, we just add these together, and that will give us our total area of this rectangle. Or it will give us the product of multiplying this monomial by this polynomial. So we get 21x to the fourth plus 56x to the third and plus 49x squared. So that would be our final answer. And if you want to check it, I encourage you rewrite it using parentheses, 7x squared multiplied by this expression here, and then use distribution, and you should get back the same answer.